Hi, everyone, and welcome to Building SaaS on AWS. My name is Gunnar Grosch, developer advocate here at AWS. And if you are building or planning to build a SaaS product, this is the show for you. I have this bi-weekly show where I bring on SaaS experts to talk about SaaS-specific topics. And we dive deep into those topics so you can learn more about building SaaS on AWS. And as always, we want it to be highly interactive. So if you have questions, comments, you just put them in the chat and we'll do our best to answer those. And this week, I'm happy to be joined by Josué Lima from Pegasystems and Steven Warwick, a colleague from AWS. Welcome to the show, both of you.
Thank you.
We start off with our normal round of introductions. So Josué, let's start with you.
Yeah, so first of all, thank you very much, Gunnar and Steven, for the opportunity to be here with you guys this morning or afternoon at your time, Gunnar. So yeah, my name is Josué Lima. I'm a director of engineering here at Pegasystems. Here, I lead a few engineering teams in driving innovation and delivering modern cloud architectures for clients of all sizes and across many different industries. So how I like to say to my colleagues, I'm passionate about serverless technologies, which maybe have been part of my life for the past 6 to 7 years. I have a very interesting relation with AWS. I come from a startup background where you need to put things live and catch up with the market and the change in our environment very quickly. And I found that serverless technology is a great tool to have under your belt to deliver successful projects and applications that will make a very high impact to your customers. So I'm very excited to be here today to talk more about those things.
That's great. Great to have you here, Josué. Steven, quick introduction.
Hi, yeah, Steve Warwick. I'm a solutions architect with AWS. I've been with AWS for just, I think, a few days shy of 2 years now. I'm in the ISV segment, so Pegasystems is one of my customers that I've been working with since I started, and feel like we have a great relationship. I'm also a member of the SaaS technical field community, and it's been a great experience with that, leading in with ISV customers. A lot of them do very similar things. So it's been a great experience building these things out, having a builder relationship with the customer. And be able to show some of the things that we built together and some of the value I hope that we bring to our customers specifically in these areas as well.
And if you're joining us for the first time, you perhaps don't know exactly what we do on this show, but we try to dive quite deep into the technical stuff on this show. So be prepared for us leaving just these talking heads. We'll dive into code, we'll dive into architectures, look at services in action. And this week, we're going to talk about Websocket rate limiting in SaaS and how Pega has built around that. So maybe we should start by you telling us a bit more about Pega to begin with, Josué.
Sure. So Pega helps companies of all sizes to crush the complexity of their business. So we work across many industries, providing a low-code platform where clients can build solutions ranging from customer engagement, case management, intelligent automation, and customer services. So here at Pega, I work more specifically with the customer service organization. And even more specifically, I work building the Pega digital messaging service, which the topic that we're gonna be talking about today.
Cool. So should we perhaps look at an example of what you're actually building with at Pega, so we know what we're going to dive deeper into later on?
Yeah, for sure. So I'll be sharing here just a few quick slides to contextualize the audience. So more specifically, the Pega digital messaging service, it connects brands to their customers across the messaging channel of their choice. So you can think of it like customers trying to engage with brands, like to get support about services, to get status updates on things that they are purchasing and things like that. And they use the different messaging services like social media networks, more traditional channels like SMS and email, and also fully managed services like chat applications that runs both on websites, but also on mobile phones and mobile applications. So our main goal is to deliver AI-driven efficiency across all of those messaging channels. So we like to say that we enable call centers running either on prem or in the cloud to connect those external channels. So if you look into this diagram here, we have the digital messaging service right in the middle, and it kind of makes the bridge between customers talking using their digital channels and the Pega call centers running on prem or in the cloud, right? So I can just jump here into a quick sample of one of the solutions that we have. We call it web messaging. So basically, customers, they have the ability to fully configure and to launch chat applications on their websites or on their mobile applications. The example we are looking here is an example of a website, a brand that wants to deliver customer service through their website. So after they place the chat widget on their page, you're gonna see that's kind of loading here on the right side, so they can start engaging with the service. So that can happen through bot automation, real agents on the other side. That's gonna enable that communication from end to end. So here you see that I'm starting to be served from a bot, and then I can ask technical questions. I can chat with an agent, and I can program my use flow on top of this solution. So on the other side, we have all of the automation, and we have all of the tools on the Pega platform to automate and configure and deliver the experience to the customer with very, very efficient architecture, solution, and a low-code platform.
So can we try out the widgets as well?
Yeah. So here I'm just like talking to a bot. So I'm gonna send a message. Of course, the bot is gonna say, "Oh, I don't understand what you're saying because I'm just making a quick demo." But I can ask questions about, "Oh, I have an issue with my bill." So I can verify my account to make sure that I'm logged in. I am who I am. I'm saying I am here. So they're gonna send me a link for authentication. Also, we have a few challenges here when it comes to managing the connection. So, for example, if it was a banking or a e-commerce application, I probably wanted this to be replicated across different windows and different tabs. So the application itself takes care of replicating that across different connections. That's something that we're going to be talking more how we achieved the solution in a few seconds with Steven.
Oh, that's cool. And I think this is a use case that a lot of people are familiar with these days, seeing these kind of chat widgets with bots available in a lot of different places. So yeah, go ahead, Josué, sorry.
Yeah, exactly. So the value that you get here is all of the automation that you have behind the scenes to provide a use case like this. So customers, they don't need to worry about provisioning a chat server. They don't need to worry about managing all of the distribution of the contents that will come from reliable and high available services like CloudFront, S3, and all of that. So AWS and the technologies that we use behind the scenes allow us to deliver such a high performant, high scalable, and in a solution that our customers can be confident that will support a very large number of customers on their side as well.
So talk a bit about some of the requirements that you had for this system.
Sure. So let me switch back here into the deck. So So this is a multi-tenant application, right? So the service itself, it runs in the cloud, connecting to the customer premises, either on the on-prem or in the cloud. So this being a multi-tenant service, we had a few concerns to begin with. So first of all, we want to rate limit inbound connections per tenants. So basically what this means that we want to make sure that one tenant won't be impacting other tenants, as their capacity and their loads will be different depending on their use case. So that was one of the first requirements that we had. Then we need to think about an infrastructure where we could tie connections together. So it's very easily that we have use cases where customers, they will have multiple tabs open, they'll have multiple devices linked into those chat conversations, and we need to find a way to broadcast that information very efficiently and in a very scalable manner across all of the components of that conversation. Also, we need to have some limits on the number of connections that we can have, both for tenants, but also for users having conversations. This also touches a little bit on the security side, so we want to avoid a little bit of the abuse that malicious users can find out there, but also set a few boundaries on the service itself, so we make it a little bit more predictable. Also, we want to rate limit the number of messages, so we don't downgrade performance of the systems downstream, right? So this service running in the cloud with serverless technologies, you think right away it's very robust. It can handle a lot of data, a lot of traffic, but the systems downstream, they need to be prepared for that as well. So one of the key concepts here is to have the awareness that other systems, they need to work on their own basis. So you don't want to be floated on your call center with so many messages that you can't handle with the infrastructure that you have in place. So that was a very important requirement for us to understand those limits and to create mechanisms where customers can build on top of them.
So some of these limits, are they also tied to different, say, tiers in your solution, so customers can have different types of limits depending on a package, for instance?
Exactly, and this is a very interesting topic because for sure customers, they have different requirements. So we have customers that their load is going to be very predictable, it's very consistent, but we have customers that where you can expect anything. So you can imagine, for example, a travel agency, and then out of the blue, they have a problem, let's say in an airport where flights can't depart. So immediately you're going to have a lot of people going into that chat service to get support, to understand what's going on. And then you can have very inconsistent load traffic in your network. So that's also one of the great things about serverless technologies is that you can easily adapt to those kind of unpredictable traffic. So you can rely on what is there out of the box to support your most dynamic use cases.
We also, I think we talked a little bit about when we were discussing this, like malicious actors as well. There's some people that just, don't like the world and they want to, do something bad. So that this is to help with that as well. If there's a brand that's using this type of service, protect them against someone that's going to be flooding their systems with that kind of bad information.
Right.
Yeah, no, I think that's a great point to make as well. That type of events can actually happen in these systems. So we have a question from the chat. So let's bring it on. So why do you want to limit connection per tenant? Don't you have a way to scale the underlying infrastructure as workload increases?
That's a good point. So sometimes we don't have a lot of control under the customer premises. So thinking through that perspective, it's better that you let the traffic keep running and you have the customer layer prem to still be able to attend their customers rather than just hammering their end with so many messages that will potentially block their systems. Of course, we have a modifying process to understand what's the capacity on the other side. But another aspect that I can say is also to set boundaries, so the customers can work on top of those limits. So I can tell you an example. So few months back, we have a huge spike in the number of requests that we are getting into one of our clients for the banking space. So requests went so high that their system could handle that anymore. So one of the things that we can do is detect those anomalies and then put the system down until the customer on their side can adapt to that kind of load. So because we have the ability, depending on that load, to turn on and turn off the system. So knowing those limits, we think it's a better approach on how to on how to make things more efficient and provide a better quality in terms of the service that you are offering.
The other thing to mention is the like if you have a tiering structure and the backend system is tiered and you're capped at a certain amount because that's what you're paying for, you don't want to overload have the front end overload the back end that they're paying. They can only go so high because that's what they're paying.
Yeah.
And based on what you answered there, Josué, does this mean that you are able to adjust these limits based on the specific SaaS tenant and depending on what type of systems they are running?
Yes, exactly. So those are dynamic configurations. Steven, in a few minutes, he'll go down a little bit more into an example of implementation, but that's something that we can adjust depending on the tenant. We have different levels of tenancy. So we have tenants that they can be grouped together. We have tenants that they require more bandwidth, so we deploy them on a more isolated fashion. And we have tenants that needs to be fully isolated because of compliance with security protocols like HIPAA, FedRAMP, and others. So this kind of architecture allow us to deploy across many different scenarios.
That's great. And thanks for the question. Keep your questions coming. This is Building SaaS on AWS, joined today by Josué and Steven. We're looking at Pega, and right now we're walking through some of the requirements they had when building this solution. So is it time to start looking at what you actually made out of these requirements then? Let's see some architecture maybe.
For sure, yeah, and I think that's the most interesting thing about this is to look into how we actually deliver such an architecture, right? So this is our high-level architecture diagram where I have selected the more important components for this presentation. So if you read this diagram from the left to the right, you have here customers engaging using the channel of their choice. We're going to be focusing today on the chat service that I quickly demoed before, because that's the one that uses WebSocket APIs. So we provide, in first place, two endpoints. One is an HTTP API provided by API Gateway, and it's fronted by CloudFront. So that HTTP API is used to start and request a new chat session, right? So once the widget's loaded on the page, it's going to hit that API and say, hey, I want to start a new conversation. And it's going to return the session ID to the chat client you see on the screen. The same works for mobile applications or customers that use our SDKs to implement the WebSocket API as well. So you might be asking why you have such a CloudFront in front of this. Couldn't you do that directly from API Gateway? The answer is that we use CloudFront to also cache the widget assets. So if you see that widget application, the chat, that's a React application that runs in the browser, and everything comes to CloudFront, comes from CloudFront. So after the user has requested a new chat session, then the WebSocket API comes in place. So we start a new WebSocket connection at that point, and we start that with the session ID. Oops, sorry. Yeah, so after the session is established, then you have the communication. We use internally a custom authorizer in a Lambda to make sure that the session is valid, to check configurations on DynamoDB, and let that connection be established or not. After that, users will start typing away. Hey, I need help with this, with that. Bots will respond back. If there is an escalation to a real to a human agent, the same infrastructure is used as well. So the flow of the message, it will happen from API gateway. Once we deliver that message to API gateway, there will be a small VLT, velocity template, to get a few information about the message payload and push that message directly into an SQS queue. So from SQS, there are batches of messages that we put together, and then it will invoke a Lambda function as the next step. That Lambda function will validate the payload, make sure that everything's right. We validate the schema, understand what kind of message that do I have any attachments here? Do I need to call any external service at this point to validate the message? And then it goes into another queue to proceed with the delivery. So the SQS queue for delivery will bulk message that will be sent forward to the call center on-prem or in the cloud. So there will be another Lambda function in the pipeline that will handle the delivery itself. So it pushes the message downstream to the Pega customer service application running either in the customer premises or in the cloud that uses an HTTP connection and a webhook on the other side to push message. We have implemented a few retrial mechanisms here just to make sure that if there is an issue, we guarantee the deliveries on that side. And then the inbound communication flow is complete. At that point, it's up to the customer service application in the call center to handle that message, to extract information using AI machine learning to understand who's the customer, get context about the user backend. Maybe he's coming from a website that's having a failure, or we have detected that this customer is kind of moving on around the site for like 10 minutes. So we want to offer proactively support on their needs, right? So after that process is done, there is a message back to API gateway, an HTTP API, that will connect directly to a Lambda function in this case. In the Lambda function, we will identify who's the customer in question that you are trying to reply to, and we will push that message through the Websocket connection, and it gets replicated across any of the tabs or applications that that user is running at that moment. So that's the high-level architecture of this implementation. We have many other components, and we can deep dive into a few of them as questions come. So just one last thing here at the bottom is about the deployment. The solution is fully serverless, including the deployment pipeline, where we use AWS code pipeline to automate everything.
So tell us a bit more about the reasoning around putting the messages onto queues before they are processed with an AWS Lambda function.
Yeah, that's a good point. So there is one first aspect of this, right? So and it is ordering of message, right? So we want to make sure that when customers are typing message, the CSR on the other side, we receive those messages in order. So the conversation actually makes sense, right? So using SQS with a FIFO queue that guarantees the ordering of things allow us to do that rather than having a direct connections from an API gateway to Lambda. So as the Lambdas will go scaling, there'll be a chance that things will get out of order as the user starts typing messages, right? So SQS is a way to guarantee that. The second thing here is about the scalability of the system, right? So if you have API gateway talking directly to the Lambda, you kind of bound the limit there by one versus one, right? So one message results into one Lambda execution. By using SQS, you can group many messages to be processed by one single Lambda. So the initial limits for Lambdas is 1,000 concurrent executions. So if you think about FIFO queues, for example, you can group 10 messages, right? So one execution can process 10 messages at a time. So you tenfold your processing capacity right there. So that's another reason. And the last reason, I mean, there must be many others that people will identify in their use case, but it's also about costs, right? So by grouping messages and making it process in batches, you reduce the costs of Lambda executions as well. Also, one thing very important is that by using SQS, you kind of have the benefit of retries, right? If for some reason Lambda fails, the message will get back to the queue and it will be automatically retried. So that's something that doesn't happen when you use a direct connection from API gateway in Lambda. You need to somehow tie that into your client implementation to identify those things.
Right, that's great. And out of this architecture, is everything here used by all tenants, or are these split up? So you're using some sort of silo architecture as well with different queues for different tenants, or?
Yeah, so that ties back a little bit to what we were talking before, right? So this is a general architecture that can be used by any customer. So what happens is that we have a customer with a special requirements that, for example, I'm going to have a lot of traffic and I want to make sure that I have dedicated capacity there. So what we can do here, you see that there are queues here in this process. What we can do is to launch one specific queue for that customer through our automated deployment pipeline and have their own lambdas, right? So we can provision a dedicated path for their message. We can also provide an API gateway that will tie directly into that isolated SQS queue. So that's one level. The other level is to deploy this exact architecture into a different AWS account in case we have a more elevated security requirements, and then and customers that wants to be on their own environment.
And then to go back to the sessions that you talked about initially, I think you've answered this already, but let's just point that out once more. Why are you using sessions in this solution instead of having the individual connections?
Right. So one important factor here is to understand is that call centers, they have different availability, right? So that can range from the time where they offer support, and also from the kind of load they have. They want to be off during high peaks, for example. So starting a session through an HTTP API in first place allows the experience to be allows the customers to have a better experience, because in first place there will be a verification: is this service available at this moment, right? Even before trying to start that connection. So if it is available, if it's not available, why it's not available? It's because we are busy at the moment, so we can provide a message saying that the wait time is too long, please wait a little bit. Or, for example, we are out of service for today, please leave your message and we return to you in another time. So in those cases, you don't need to have a WebSocket connection at that point. Another thing is that, as I mentioned before, you can have multiple tabs running your conversation. So when you start a session in first place, you can group all of those connections together, which make it so much easier in case you want to synchronize the conversation across different devices and different tabs. So that's a great advantage of the session itself. And it also allows you to better track the message that a specific customer is sending back and forth for rate limiting purposes.
All right, cool. So, Steven,
yes,
should we?
I think that ties in nicely to our next session, our next section, going over a little bit of this. So, I'd like to talk a bit about, like, Josué has shown like a complete architecture across of what Pega does. We also built together kind of a part of that, and if you can kind of think of it as like the message part into all the lambdas, and then when it hits, like if you're looking at the diagram here, the tenant part would be where you actually send it off to the Pega system. So this sample is available for anybody that wants to look at it as well. But this is the generic version of what Josué is talking about that breaks it down into individual parts. The pooling and siloed that you mentioned there are broken out into the sample as well to show like, hey, if you wanted to do pooled, have a bunch of tenants together to share that, share those services versus an individual client might need that siloed environment that needs their own capacity for things because they're larger or they have spikier workloads, that kind of stuff. We also talked about, how do you store those sessions? So we're using DynamoDB right now. There are other options that you could do. Again, I think Josué mentioned this. It kind of depends on your price point, your performance that you require for that. DynamoDB handles this very well in this type of situation, though it's fairly cost effective. And I believe Josué's team was already building out or using DynamoDB, so it just kind of happened to slot in really well for the particular thing that they were doing. But what I'd like to do too is let's drive into these. Let's look at what those tables look like. What's the VLT stuff, the transformations that happen in API Gateway, how it goes through the system. So one thing I'll jump into here is I want to go into those tables that we were talking about. So we mentioned that we had some tables in the background and that the things were dynamic. So we have a tenant table here. So you'll see 3 different tables. One's for limiting, one's for the sessions that we were talking about, and one's for the tenants. And we have a bunch of fields in here that can track for a particular tenant. We're going to say, hey, they can only have so many connections per session, number of messages they can have per minute overall, and then sessions per minute, how many sessions they can constantly create if they're and then we also have a time to live, and the session time to live is important as well, so that we can, if someone's sitting there idle for a long time, we can drop them. API Gateway has its own, but we might want to kick them off a little sooner. And we also have, we'll come back to this, there's the time to live that we use in the session table as well later on to automatically kick off the connections that are just idle. And then we've got the total number of tenant connections we can have, and if I can get on here, the tenant per minute, how many connections overall for the tenant. So we have a whole bunch of knobs that we can tweak per individual tenant. This allows to control the flow through things. This isn't, we talked about siloed and pooled there as well. That doesn't come into play particularly here. That would be more on your deployment model where that particular tenant would be deployed out to, and then they would follow that path. If we look at, I don't think there's actually anything in the session table right now. So what I'm going to do is run a demo. I've got a demo client that's a very chunky version of the nice thing that Josué showed. So
you're telling me you're not the front-end engineer, right?
By no means a front-end engineer. So this is kind of what happens in behind the scenes for things like this. Typically wouldn't be done. They would already know what tenant there are. I did this for a particular sample, so it's easy to use. But in behind the scenes for a chat widget, there would be some automatic thing that would say, okay, go create a session. And then once that session is created, and in behind there, you could put in some authentication there. Like Josué mentioned, you can put a bunch of checks in that session that happens there. Then we can do a connect. And if we go back to here, we'll see that there's the time to live that gets set here. And we want to kind of take note of this number here, this 874. There's a single connection right now for this particular session, and it's on a tenant. So as we go back here, if we send this particular tenant set up to be a pooled, so I'm going to send a pooled message, and you'll see that we got a response back. One thing I'm going to also do here is that duplicate. So this is very similar to what Josué was doing. I'm going to connect. So this is the cross browser that sent a message, and you'll see that it duplicated over here. One thing I want to note is when we go back into here, now we've got 2 connections inside of here. So I'm showing this just to show a little bit too of like the actual rate limit. I don't think when Josué is showing the next one, we didn't really get into rate limit. But if I just start hammering away on this, I'm going to start to get a bunch of throttled messages, and you'll see that it just stops on both sides. So even if I send on this side, it's going to say throttled as well. So that session right now is completely throttled. So I'm going to go back. Sorry, I bounced a little quick there. I'm going back here. We're on the session table that shows we've got a session. That time to live value gets updated for every message that comes in. So we know they're active. We're updating that time to live. But on the limit table now, if we run this, you'll see that there is a bunch of limits in here, or counters in here. And a lot of them will say per minute or minute message. So what we did is we just said, okay, let's count you by tenant, and we'll put in a key that's an aggregate of a bunch of things. So this is an aggregate of the tenant and tenant information, the number of messages, and then you'll see one that's a tenant and a session number of minutes, messages per minute. So we've got a count that keeps incrementing. For every message we come in, we keep updating this and checking on it. And you'll notice there's also a time to live, so it clears out the database for us. One other thing to note is these are all locked down by the tenant ID. So when we get into the code of showing like how we connect to the database, we're using our keys on there to make sure when we create credentials to connect to the database that we're limiting the scope down to only the tenant that's allowed to connect to this. So this, we're using DynamoDB in a pooled model here where all the tenants' information are all shared together in one database. Again, that could be a change in depending on the application that the person needs to use. But in this case, it's per tenant.
So
yep.
Can you just tell us a bit about why DynamoDB for this? Since some parts are configuration, some are the actual sessions. Are there any options to using DynamoDB for this?
Other options like
alternatives.
Yeah, you could use Elasticache or something like that, where it's more in memory, or some other NoSQL database if you want. You could there's tons of options, and it really boils down to like what's your latency that is required, what's your price point there, right? Really you just need to be able to lock it down per tenant. So if you're using scoping credentials, whatever system you use, you definitely want to make sure that you scope it to that tenant as well, so you're not getting any cross-pollination. Either that, or you have to do a completely siloed and build it out that way.
Right.
So, did you have I know you were using Dynamo. Was there a particular use case or reason other than using it already?
Yeah, sure, absolutely. So as I mentioned earlier, this solution works not only for chat, but for many social media channels, right? So DynamoDB is in first place a perfect fit for the solution because it's schemaless. So the schema is very flexible, and it allows us to easily adapt to change on those platforms that are very unpredictable, right? So they can change, external channels can change their payloads, can change their messages without notes sometimes. So DynamoDB allows us to absorb and to be consistent with those changes because of its flexible schema style, right? The second thing is that DynamoDB is very well in line with all of the serverless applications that we have in AWS. So one thing that makes it really easy for us is about authorization using IAM. So very easily we can connect different components with very fine-grained permissions. So we can lock tenants to the raw level that they can access. So that's really a huge point for us in terms of managing multi-tenant applications in the cloud. So we can have that level of granularity on our security elements, right? And which makes it so much easier for our use case. The third thing that I would mention are a few features that DynamoDB has around automation. So one of them is the the dynamic capacity scalability. So you can just set it to scale according to the load, or you can add some provision capacity, right? So if we are going across a use case where we still are unsure about what are the loads, just enable the capacity to go as the demand increases. It's on demand, the name, sorry, on demand capacity. And the last item is about the TTL that you can have on DynamoDB tables. That makes it easier for us to make some sort of garbage collection. So once the session is over, we have a few mechanisms to clean that session out of the DynamoDB table, right? So customers can end the session on their side. The agents on the call center can end the session on their side, but sometimes things can happen, right? And then we can rely on TTL for removing those connections automatically after they expire. And then that triggers automatically a process in the backend to make sure that any components or any other items throughout the architecture are also cleaned using triggers and DynamoDB streams.
Great. All right, so Steven, should we maybe jump in to show some code as well then?
Yeah, I wanted to jump over to the API gateway as well, because I know we talked about the transition from a like a chat endpoint to into SQS, and that's one I think a lot of people get stuck on this, because we do have some examples of it, but it's a little difficult to find. So this does show, you'll see here, there's a siloed and a pooled, and really that just is the endpoint that you're going to be hitting on your path. So in this particular one, you'll see here there's a queue that gets added here as an parameter, and that would be replaced with your tenant ID or just the word pooled if you're in a pooled model, or some sort of thing there, depending on what you're going to be building out. And one thing is here is in the request template is what we're doing is using the send message. And this is where Josué was mentioning that we can break out some of the message and some of the context stuff that's inside of from WebSocket going into SQS. So you'll see here that we're using the Authorizer tenant ID. So we will get into the Authorizer Lambda as well that gets hit. Inside of that Lambda Authorizer, we set up the tenant and session ID and a bunch of other parameters. And then when every message that comes through, we can template that out and send it into the send message call for SQS, which gives us a bunch of metadata once the SQS Lambda gets processed as well. So we're not constantly having to hit the database to keep getting this information. We can pass it through. So you'll see here all that metadata about like the settings, the different actions that are there, and then we obviously pass along the message as well. So let's get into a little bit of code, as we said. So let's look at the authorizer first. So this is, if we look at the stages of what we're doing, the first thing we do is come in and hit the authorizer, say, hey, is this valid to connect? So one of the things that we're first doing is creating a database connection. And when we first hit the authorizer, the tenant ID in the sample, the tenant ID in the session are based off of the parameters, the query parameters. So you'll see in the common code that we can get the tenant ID either from the query parameters, or if we've already done a request, we'll just get them from the authorizer. But we use that when we create a DynamoDB connection. And this is where I was talking about, we're creating temporary connections because we want to scope down that connection to only the tenant that is coming in. So we're going to create credentials that have been scoped down to that particular tenant ID. And then once we get the connection, we start doing our checks inside of the database. So we also pull out the tenant settings, and we're, in this particular case, we're doing a little bit of caching inside of the Lambda itself. This is just in case we keep hitting the same Lambda, we can get some of the same information back if it's running hot. But the first thing we're going to do is just check, like, hey, is this tenant available, and is this session available? Which actually maybe is something I should jump into first as well. As we've got I'm just going to try and find it here, the session Lambda. So this is more on the HTTP side where we're creating a session. This is just a sample one. In production, you probably have something much more robust. But in the session, we're just saying if we're doing a put, they just come in, we're just adding a session. And this is where it got put into the DynamoDB database. So in here, we did a couple basic checks just to make sure that they've got a session and tenant. Again, we create the database, scope it down, and do an insert into our database. And then a delete later on, because in my sample, I let you delete it. Okay, so let's go back to the authorizer. So inside the authorizer, we've checked that we've created the tenant is valid, and now we're checking if the session is valid as well. And we generate an allow statement. If not, we generate one of these deny statements. So if we look at the common code, you'll see some functions in here that scope out either a deny, allow, or a deny, and that goes into just generating a policy. And we pass the effect through and for which resource it's for. You'll also notice though in this one that we're passing in the event and the tenant settings, and this is where, like I mentioned with that transform into SQS, that we're passing some information, and so we're not constantly hitting the database for that same information. So we're just adding a whole bunch of information to the tenant context about the settings and what tenant and session we have at this time.
Yeah, I'd like just to add a small comment here on that piece of code, Steven. So I think that's a great feature that we are taking advantage of, adding context information on the session, right? So this helps us avoiding unnecessary trips into the database, because you already have a lot of information here available for you as soon as you receive a request from a request or a message from the WebSocket connection. So definitely something that can improve a lot of the capacity and the costs of your application if you have too many messages that will need to look up data into Dynamo.
Yep. All right, so I'm just gonna continue on. It's a good thought though. So the next thing that we're going to do is go into the connect phase, right? So we've authorized, now we actually have to go through and create the connection. We're going to do a bunch of checks inside of here as well for those limits that we were talking about. So how many connections per tenant, per tenant session as well, because as much as we would love to, if we've got these windows open, you don't want someone opening 100 of these because that might bog down a particular session. So each individual one can limit this though to, we had the numbers in there. If you set it to 2 or 10, whatever the customer is allowed and what they're paying for, we're checking those. And then if they're over their limits, we're just sending back an error code for them. So we do a bunch of checks on those connection types of checking, sorry, a bunch of checks on the connections, and then we're going to update the counts as well in our DynamoDB database. And of course, we're always, you'll notice, updating the time to live. So anytime we get something coming through for those connections, we want to make sure that we're updating the session table so that they don't get timed out. And you'll notice in here we do things like the if not exist type statement, so that we're putting in a 0 if it's not already there, and then incrementing by 1 always. So that gets us our item count. So at this stage though, now we've authorized, we've connected, we've got a valid session, tenant, all that information. The next thing is they start sending messages. So the Lambda is actually the same whether you're in a pool, like the code for it in the sample is the same whether you're pooled or in a siloed model. It doesn't matter. That really is a function of how the queues are sending to you. So you can create a queue for, I'm just going to show the diagram quickly. You can create a queue for pooled that has 10 tenants in there. The code that's running in the sample, at least, is exactly the same for the pooled version as for the siloed version. The only difference is you get your own capacity for across the board. Again, that could change in an implementation if there's some differences in how you hand off to that third-party application like Pegasystems. If you're handing off to it, if you're in a tenant situation where it's siloed or pooled there as well, you might change the code for that. So I'm gonna go into this echoing. So like Josué said, we can handle a bunch of messages at a time, per time, per invocation of the Lambda, versus having directly from API Gateway, you'd have that single one-for-one. So we're iterating through all our records inside of here. We're building up an event just to make contextually easy to understand. We've got the authorizer we're pulling out of the message attributes that we showed earlier, where we were doing that transform and putting them into the SQS queue. So we're pulling out a bunch of information that we need for this particular execution. We're also pulling out the connection ID because we want to be able to connect, send a message back. So we need that connection ID and the request in the body. I pull out the queue name just because in the demo, when I pair it back, I want to show you. If we go back to here, you'll see it'll show what inside the message what the action was if you were in a pooled or a siloed environment. So as we go into here, though, we'll notice that we start hitting these increment rate limit table per minute type of things. So in this, we're checking how many messages per minute that this particular session is taking up. And if we look at the code for this one, is in the common code. So what we're doing here is we're just saying we insert a new record into the DynamoDB database for every minute chunk. So we're truncating the epoch disk down to a minute. So as we go, we'll say, like, as the minute rolls over, you'll actually insert a new row into the database, and we use the time to live there as well to clean out those records, as we mentioned, right? So we're constantly adding those minute messages and then cleaning them up as we go, but we're incrementing them as messages are coming in as well. So we're just doing an upsert type of idea. And again, it just does a increment right here. So once we know if they're over their limit, we're going to do create a throttled message, which is again in the common code. So if we look at that, all it does is say too many requests and pass it back. So some people might say, well, that's still responding, but the main idea here is to stop as soon as possible and not put more pressure on the downstream system. So if we didn't at least send that throttle message back, and hopefully we have on the other side, there would be a nice player. If there is a malicious person, they could ignore that and keep sending, but at least we're limiting the hot or the load to our serverless environment and versus going to our downstream system, which we're not sure if it's available or not, any of that kind of stuff, right? So we're taking the load and lopping it off at this point. So that would create a throttle message, but if not, then we can come through. We can then cycle through all of our connections inside of here and post back. In this case, this is where in a real world environment, we would actually execute out, put it like Josué puts it onto another queue to go off to the Pegasystems running on-prem or in cloud. In this particular one, we just post back to all the current connections, like a parrot back, and then we also post back to our existing connection as well. So that's how we get the back and forth here, where you'd see, this one got sent the same messages that the other one had. So there is a couple other little chunks of code in here. We'll see that there's a session TTL. So this is the Lambda that gets hit when in the session table. If that TTL hits, we're going to go and grab the connections from that and then disconnect or delete all the connections available for that particular session. So that clears everything out if we have somebody that's lingering for over the amount of time that we want to get rid of them.
Cool. So The inactive connections, you mentioned that they are removed using the TTL in DynamoDB, but there are other mechanisms to remove inactive connections as well.
Yeah, like API Gateway has its own particular disconnect. So we also have a disconnect lambda just in case we get a disconnect trigger from API Gateway, or if the client disconnected itself. This allows us to go back in and clean up that session information as well.
Right. All right. So we are approaching top of the hour. So just a few more minutes to go. Any last things we want to show, Steven, on this solution? Anything around the deployment, perhaps?
Right. So this is all built out using CDK. You could obviously build this out with anything you want, but I've got a Java background myself. I think Josué and team uses various different models of deployment as well. But this just makes it really easy to build out the system, not have to worry about, is every permission correct? Because that's one thing I love about CDK is you just say, hey, here's my thing. Here's my database. Can you grant access to this Lambda? And it does the limited permissioning available needed to actually grant that access, which is great. It's kind of less I have to remember to do. But this CDK is available as a sample. It'll go in and create everything for you. You can just use CDK to deploy. It goes through and creates example siloed queues as well as a pooled queue, creates the sample website for you and everything, and you're off to the races.
That's great. And our friend Bill has shared a link in the chat. He can possibly share it again to make sure that everyone is able to check out that blog post and the samples. So, Josué, any final things you want to mention about Pega and the solution you built? Any things you want to perhaps put in the mind of SaaS developers out there?
Yeah, so I think it's a great opportunity building such high demand and workflows on top of AWS, because they allow you to go much far and rely a lot on the operational and scalability and security of AWS itself. So you are ready to go and focus on the business value. So yeah, just to finish, I'd like to thank you very much for the opportunity to be here. It was great talking to you and to the audience. If I can leave one final message, is about our annual event, the Pega World, which is happening in May. It's a free event online where you can learn more about Pega in general, the products, the things that we're building around customer service, voice AI, messaging, and all of the customer decision things that we do, artificial intelligence, and so on. So feel free to reach out, have a look into our website, and register for free if you want to learn more about us.
That's great. And I shared a link to Pega World in the chat now, so do check that out. And then I want to thank Josué for joining, and Steven as well, walking us through these examples and this production system from Pega as well, to see what you've built as a SaaS solution on AWS. And finally, thanks to all the viewers for joining us today. This has been another edition of Building SaaS on AWS with me, Gunnar Grosch. Happy that you joined us today, and we will be back again in 2 weeks. Thank you all very much.